All right, for this last set of examples, I actually have a guest host in here with me. It's Mr. Lou.
Hi, everyone.
Cool. So we're going to look at a proof here for proving the alternate interior angle's converse. Now remember, when we're doing proofs, we can use whatever we've learned right before. So in this case, when we look at it, we're going to be given 4 and 5, because those are marked on the figure, and we want to prove that the lines are parallel. So we don't know that alternate interior angles prove that the lines are parallel, but we do know a couple of other things. For this proof, we're going to start out with what's given, and then if we look carefully, we know 1 and 4 are congruent if we go back again, because 1 and 4 are vertical angles. Okay? So we go forward, and we know 1 and 4 are vertical angles. And then if we look at these two lines, you can tell that 1 and 4 are congruent and 4 and 5 are congruent. So therefore, we can use transitive property to prove the first and the last are congruent. And then after that, we can state that the lines are parallel, because if we go back and we look at 1 and 5 real quick, 1 and 5 are corresponding angles. So since we already know corresponding angles prove the lines parallel, we can use that idea in this one right here. So we use the corresponding angles converse. In this next one, we want to prove 1 and 3 are congruent. And we're going to go through this slowly just to show how it works. We know that R and S are parallel, so we can state that 1 and 2 are congruent. And then we want to prove P and Q are congruent, so I believe then we can state that...
we're looking at 1 and 2 then.
Right. So we look at 1 and 2 first, and we can say that that's true because R and S are congruent. And then I believe we're going to look at 2 and 3.
So by showing 2 and 3, we can just say that they are congruent because of the converse, then they would be parallel.
Right. And because we already know that 1 and 3 are congruent, and we know 1 and 2 are congruent, then we can state that 2 and 3 are congruent. So this is the strategy you want to go through whenever you're doing a proof. You want to see, does it make sense? Well, we know 1 and 3 are congruent, and we know 1 and 2 are congruent. So therefore 1 and 3 will be congruent as well. So they're going to lead us through this as well. So we look at the ideas, and we know we're going to look at angles 1, 2, and 3, and we know that we want to focus on just one set of parallel lines and one transversal. So we're going to be looking at RS and Q at first. So if we look at 1 and 2, and we look at just R and S being parallel, we know these are corresponding angles. Okay? And then we look at 2 and 3. Now 2 and 3 have the transversal of line R and these parallel lines. And we know 2 and 3 are, if those are congruent, then those lines are parallel. So this is where we want to be. So now we put it into action, and this is more written as a paragraph proof, which we won't be using, but it's basically just writing out the statements and reasons as sentences. So we know R and S are parallel, therefore angles 1 and 2 are congruent. Then we can state that we know 1 and 3 are congruent, and we can state that 2 and 3 are congruent because of the transitive property, although I wouldn't call this transitive property in this case, because we have 1 and 2 congruent and then 1 and 3 congruent.
Well, you can go the other way around, so you can go 3 congruent to 1, and then 1 congruent to 2.
Right. If we had written this as 1 or 3 congruent to 1, then we could do that. But I think in this case this would be much more of a substitution property. But we agree to disagree, I guess. Therefore, since 2 and 3 are congruent, by alternate interior angles converse, we know the lines are parallel. Alright, for this next one, all we're doing is we're trying to see, is this top stripe parallel to the bottom stripe? Now, we know that the first stripe is parallel to the second stripe, the third to the fourth, or the second to the third to the fourth, etc., all the way down. So if all of these lines in between are parallel, then the first and the last are also going to be parallel. We call that, I think it's called the transitive
property of
parallel lines. So in other words, 1 and 2 are parallel, 2 and 3, etc., all the way down, so we can state that 1 and 13 are also parallel. Now here's some quick ones. We just want the given and the proof for this one. We're given that 1 and 8 are congruent, and we want to prove that the lines are parallel. So we would say that given is angle 1 is congruent to angle 8, and we want to prove that J is parallel to K. And now we want to do a basic proof of the alternate interior angles converse, and we're using the diagram in example 3, and I believe that diagram, is that the one that looked like this? Was that the one? It should be that one. So let's see. Let's go back to it real quick. Let's go back and get that example 3 thing.
Yeah, you guys have to do two proofs that are very similar to the example 3, so make sure you pay attention.
Right. Okay, so we've got 1, 4, and 5 there. Okay. So this is, we've got 1, 4, and 5. Let's go through this real quick. Alright. So I'm going to draw it again. We've got that, that, and that. And I believe we had a 4 here, and a 5 here, and a 1 here. So we're given that 1 and 5 are congruent, or 4 and 5 are congruent, and we want to know why 1 and 4 are congruent. That's because of vertical angles. And then by the transitive property, 1 and 4 are congruent, so 4 and 5 are congruent, so therefore 1 and 5 are congruent. And since 1 and 5 are corresponding angles, then the lines are parallel. So this is basically the same as example 3, but they wrote it as a paragraph proof.
Make sure that you guys write the word converse in your statement, so this way you know that you're trying to show that two lines are parallel.
I agree. Make sure, because in the last section we used just corresponding angles postulate or alternate interior angles theorem. Now we need to make sure that you're talking about the converse. If it's a converse and you leave that out, then you lose points. So again, vertical angles give me 1 and 4. By the transitive property, 1 and 5 are congruent. And then by the corresponding angles converse postulate, the lines are parallel. And this last one is similar to the one with the stripes. We want to know if all of these lines for the stairs are parallel. And in that case, again, we use the transitive property parallel lines so that the top step is parallel to the ground, just like the bottom step is. And that's it. Thanks.